2.3b is about real-world modeling of linear situations. So essentially, we're going to look at word problems. We're still going to write an equation. We're going to define our domain and range, and then we're going to take it a step farther by graphing these situations. So just a reminder that our y-intercept is also known as the starting value in a situation. So for a lot of these problems, that y-intercept where x is 0 and y is our b value, that's going to be where these problems start. Okay, let's look at a situation. So this first one, each member of the volleyball team would like to buy a sweatshirt. Well, there's a setup fee of $10 and each sweatshirt costs $20 to make. So you should always start off word problems by defining your variables. So we don't know how many sweatshirts people are going to buy. Okay, that's what we don't know. So I'm going to let x equal the number of sweatshirts we're going to buy. Well, if that's our input, how many we buy is our input, then our output, okay, our y is going to be how much those sweatshirts cost. So x is the number we buy, y is what we have to pay for them. Now that we have this information, we can use it to write an equation. We're going to write it in slope-intercept form. So y equals the cost of our sweatshirts equals, we can take a look at our problem again. We have to pay the setup fee and we have to pay $20 for each sweatshirt, for each shirt. Okay? So y equals 20x plus the $10 setup fee. Right? That's our $20 for each shirt plus $10 just for talking to that company. So here we have an equation to represent our situation. We also want to be able to represent this equation using a table of values. Okay, so just by looking at our equation, we can identify our starting point, right? So if we're looking at this, our equation tells us that our y-intercept is 10. So that means when x is 0, when we buy 0 shirts, we still have to pay $10. Okay, remember, that's our starting point, because if you think about it, we couldn't start any lower than that because it wouldn't make sense to buy a negative number of sweatshirts. All right, so that's our starting point. To find other values, there are two things we could do. So that first thing is just to pick an x value and plug it in to find y. So I want to know what happens when we buy one sweatshirt. So if x is 1, that means y is equal to 20 times 1 plus 10. Well, 20 times 1 is just 20. 20 plus 10 is 30. So when we buy one sweatshirt, we have to pay $30. That's one way we can find our table of values. We could keep going, again, picking x values and then plugging them in to find y. We could also graph our equation and then based on our graph, finish up our table of values. Either way, you need 5 points. Remember, you should always have 5 points for these table of values, so 5 ordered pairs. Doesn't matter which method you pick, it just is personal preference. So looking at our graph, notice how I got to draw my x and y axis. So I drew them, right? So I drew them. So right here is my y axis, right here is my x axis. Okay? I didn't draw it in the middle of my coordinate plane because I am not going to need any of the other quadrants. Okay, I'm not going to need any negative x values, so I didn't include them when I was drawing my x and y axis. Let's go ahead and label our x and y axis. So we label our x and y axis appropriately. So I wasn't going to have enough room to get up to like 30 for my y value, so on my y axis I counted by 10. So I went 10, 20, 30, 40, 50, so on and so forth. So that's my y-axis, and I know that's my y because that's how we defined our variable when we started the problem. So our x-axis, it represented the number of sweatshirts. So we could get 0 right here in this corner is our origin, 0, 0. Okay. So we could buy 1 sweatshirt, 2 sweatshirts, 3 sweatshirts, so on and so forth. So now that we have our x and y-axis all set up, we can start graphing. Well, we're going to start with our y-intercept. Remember, that is our starting value. So I'm going to graph 0 sweatshirts is $10. So right here, that's my y-intercept. I could use my slope in order to keep graphing. So my slope over here is 20. Well, I want to make that a fraction, so 20 over 1 tells us that our rise, we're going to go up $20 each time, and our run, we're going to go over 1 sweatshirt. So I go up 20 and over 1. Notice how now I have the point 130. That matches the point we found algebraically in our table. Let's keep graphing. So I'm going to go up 20 over 1, up 20 over 1, up 20 over 1, up 20 over 1. There. Now I can connect these to finish off my graph. Now that we finished our graph by drawing our line, we can look at those points and use them to finish off our table. So when we buy 2 sweatshirts, we have to pay $50. When we buy 3 sweatshirts, we have to pay $70. When we buy 4, we have to pay $90. Also, when we're looking at a table, just another way you can look at it, notice how our X values are going up by 1, and every single time we buy another sweatshirt, our Y value goes up by 20. Right? So there's this linear pattern. So we can use that linear pattern to write more values in our table also. If we buy 5 shirts, well, 90 plus 20 tells us that when we buy 5 shirts, it'll cost $110. So there are several ways for you to be filling out this table. We have our equation, our table, and our graph. So we have represented this word problem or this real world situation in several different ways. Let's take a look at another problem. The current temperature of the water is 50 degrees Fahrenheit. You are heating the water on the stove and the temperature is rising 20 degrees every minute. Okay, so of course we want to start off by defining our variables. All right, well, we don't know how long we're going to be doing this. So we don't know how many minutes. So that'll be our X. So X is the number of minutes, right? Because we have rising 20 degrees every minute or 20 degrees per minute. Well, if X is the number of minutes, then Y, so our output, is the new temperature, right? The new temperature that we're going to get. So if we represent this as an equation, we are going to say that Y, our new temperature, is equal to 20 times X plus that starting point of 50 degrees. Okay? So 20 degrees for every minute X plus that original starting point. We want to be able to state the domain and the range of this problem. So if we're thinking about this, where could X start? Well, we're talking about time. We're talking about minutes. And you can't have negative time, again, unless you've got that time machine out in your garage. So that means that 0 is the lowest number of minutes we could be doing this for. So X has to be greater than or equal to 0. Okay. There's no max, right? Time's going to keep on going. It didn't give us any specifications in the problem, so there's no cap for this problem. There's no maximum. For the range, well, if X is 0, if we've been doing this for 0 minutes, the temperature is still going to be 50 degrees. So that's our minimum temperature. And again, since we don't have a max number of minutes, we don't have a max temperature. Well, now we can create our table of values. We already have one, right? We already know our y-intercept is 0, 50. Okay, and we could plug in an x value to find y. Or we could graph. Again, personal preference, however you want to figure out that table of values. I labeled my axis accordingly. My y represents the temperature. My x represents the number of minutes. And again, 50 is never going to finish, or never going to fit on this chart, so I counted each little hash mark as 10. Okay, so that's what we are looking at on our graph. Well, our starting value, that y-intercept, is 0, 50. So I'm going to go ahead and graph 0, 50. Well, then our slope tells us that 20, right? So we could write that as a fraction, 20 over 1. So we're going to go up 20 degrees for every 1 minute, up 20 degrees for every 1 minute, up 20 for every 1 minute. Then, of course, we want to draw our arrow to connect our dots, and we can look at our chart to fill in our points. So after 1 minute, our temperature will be 70 degrees. After 2 minutes, our temperature will be 90 degrees. Hopefully by now you're noticing a pattern. Each time we're just adding 20. So based on that pattern, we know after 3 minutes, our temperature is going to be 110 degrees. After 4 minutes, our temperature is going to be 130 degrees. We've looked at an equation, a table of values, and a graph for this situation. Let's take a look at one more just to make sure we have this down. Sarah has $100 in her savings account, but is spending $5 every day on coffee. So take a second and try and define your variables. This would be a good time to pause the video and try to figure this out for yourself. So X should be the number of days, and Y should be the amount of money that Sarah has left. So let's go ahead and write an equation to represent this. Well, the amount of money we have left, okay, is equal to spending $5 every day. Spending, so that means we are losing it. So we're going to have a negative $5 for every day X, and then we started with 100. Okay, I wrote it in slope-intercept form. If you had Y equals 100 minus 5X, that means the same thing. I just wrote mine in slope-intercept form. So what is the domain? Well, we have a maximum amount of money we can spend. So let's actually take a look at the range, right? Well, they're not going to let us go into debt at the coffee shop. So the minimum amount of money we can have is $0, right? We won't have negative money. The maximum amount of money we have is $100, right? That's what we started with. Well, the minimum number of days we can do this is 0, right? We don't have to buy coffee. And there is a maximum. So if we spend $5 a day, 100 divided by the $5 we spend each day tells us we can do this for a maximum of 20 days. So that's our domain and our range. Our table of values, well, just by looking at our problem, we know that on day 0, we have $100. Okay, if we plug in 1 for X, well, that means we have negative 5 times 1 plus 100. So that's negative 5 plus 100, which means we have $95 after we've done this for 1 day. So it looks like our pattern is each day we're going to lose $5. So on day 2, we'll have $90. Day 3, we'll have $85. Day 4, we'll have $80. Go ahead and graph this. Well, our y-intercept is way up here at the point 0, 100. Okay, we actually have an x-intercept for this problem. We have a specific ending value for it, so we know that after 20 days we'll have $0. So that's our x-intercept way down here. So we could connect those two lines if we wanted to use our slope. Well, we go down 5 and over 1 day, down 5 and over 1 day. Okay, so we could graph in a couple more points if we wanted. Again, take note of how I made my x and y axis appropriate so I could fit this problem onto this specific coordinate plane. And here is our graph right here. Okay. All right, so just to review, when we're talking about our word problems, we're looking at B as that starting value. Okay, remember to check your domain and range to make sure they make sense.